Modular arithmetic. Modular arithmetic is about finding the remainder after dividing one number by the mode, which is another number. Now, modular is only interested in finding the remainder. So, for instance, if we have 9 mod 5, it means what is the remainder when we divide 9 by 5? So, 5 will go into 9, 1 times remainder 4. That means 9 mod 5 is equal to 4. 5 mod 9 means what is the remainder when 5 is divided by 9? 9 cannot go into 5, so 5 mod 9 is still 5. Now there's some interesting results that we obtain whenever we add 5 to, that is, we add the modulo to the number. So if you add 5 to 9, you get 14, and if you keep on adding the modulo, which is 5, you get 19, 24. Now all these set of numbers in mod 5 is 4. So 14 mod 5 is 4. 19 mod 5 is also 4. 24 mod 5 is also 4, because 5 will go into 24. 4 times remainder 4. So this one too, we can find that set of numbers that will all give us 5. We have this was image in 2015 question. If x is such that x is greater than or equal to 2 but less than or equal to 18, and x is an integer. And also we have 7 plus x is equal to 4 mod 9. Find the highest value of x. So x is within this set of numbers. Now to do that, we need to generate the set. We are talking about this, so let's take this 7 plus x is equal to 4 mod 9. 4 mod 9, and we know 4 mod 9 will give us 4. Now we need to find all sets of numbers that if you find or you convert them to mod 9, we get 4. Now we can find that by repeatedly adding 9 to 4, which is adding the mod. So if we add 9 to 4, we get 13, and if we add 9 to 13, we get 22. And if you add 9 to 22, you get 31, and so on and so forth. So we know that if you solve this value for x, you are going to get x to be equal to 4 minus 7. And this is giving us negative 3. But negative 3 is not in this interval. So we go to the next one, which is 7 plus x. 7 plus x is equal to 7 plus x is equal to 13. Now if you solve this, you are going to get x to be equal to 13 minus 7, and 13 minus 7 will give us 8. But now 8 is within this interval, but they said we should find the highest value of x within this interval. So we'll try to see whether we can solve again, which is we have 7 plus x being equal to the next value, which is also have whose mod 9 also give us 4, is 22. Now when we solve this, we are going to get x to be equal to 22 minus 7, which is 15. So we can continue solving. So now we have x, we have 7 plus x again, 7 plus x being equal to 31. And when we solve this value for x, we are going to get x to be equal to 24. Now, x 24 is not within this interval, so the possible value for x are 8 and 15. But they say we should find the highest value of x, which is 15. So the option C is the correct answer. Number bases tell us how many different numbers we are using to represent a given information. Humans use 10 different numbers to represent a given information, whilst computers use 2 different numbers, that is zeros and ones. Computers understand this, humans also understand this. Now there's a need for us to convert from one base to the other. Let's look at how we can do that using an example. We want to convert 35 base 10 to a number in base 2. So we use a table that can help us do that. Now we have, this is the base we want to convert to, which is base 2, and the number given to us is 35 base 10. Now the remainders is what will give us the required result. So now we divide repeated by 2. So 2 going to 35 17 times, remainder 1. Then 2 is going to 17 8 times, remainder 1. 2 going to 8 4 times, remainder 0. Then 2 will go into 4 2 times, remainder 0. 2 going to 2 1, remainder 0. Then 2 cannot go into 1, so write 0, then repeat the 1. Now we write in the reverse order, so it becomes 1 0 0 1 0 0 1 1 base 2. So 35 base 10 base 2 is this. The option is C, is the correct answer. Now let's convert from other bases to base 10. To do that, we need to find the value of their digits and add them. So that is how we convert from other bases to base 10. So we multiply 1 by the base, which is x, to the power 2, that is the value of 1. Then plus the value of 2 is 2 times x, 2 times x to the power 1. Then plus the unit digit, which is 4 times x to the power 0. The x to the power 0 will give us the unit digits, and in that order. Then this will give us 7 into 1 times x to the power 1 plus 4 times x to the power 0, which will also give us the unit digits over there. Now what we do is to simplify now. So 1 times x will give us x, that is 1 times x will give us x squared, then plus 2x plus 4, then this will give us 7 into x plus 4. Now we expand the right hand side, so we have x squared plus 2x plus 4, x squared plus 2x plus 4 is equal to 7x plus 28. 7x plus 28. Now we group like terms, so we have x squared plus 7x, x squared plus 7x is rather x squared plus 2x rather. So we have x squared plus 2x rather x squared plus 2x, then minus 7x then plus 4 minus 28 is equal to 0. Now we simplify, so we are going to obtain something like this: x squared plus 2x squared minus 5x, then this will give us negative 24 equals 0. Now we factor this to obtain something like this: x plus 3 into x minus 8. So x minus 8 equals 0. So now either x equal 8 or x equal negative 3. X equal negative 3 or x equal 8. But x cannot be negative. Hence, our correct answer is x is equal to 8. Because it's a base, it cannot be negative.